Thank you to Squarespace for sponsoring today's video. Stick around till the end for more info on them and the discount code. Today we're going to talk about how to replace stepper drivers on a board like this, where it's literally just unplugging it, on a board like this one, where you can not unplug the drivers, and on a board like this one, we don't even know how the drivers are connected. Let's get to that. So blown stepper drivers, they happen. I mean, it happens to the best of us. Sometimes these little Lego chips just don't stand up to all the stuff you could do to them. Some of the ways that you can actually crash and break a driver is by, for example, moving an axis too fast by hand. So if you do like this, then you're going to induce a really high voltage in the motor that can only feed back through the driver into the supply rail. So that can very easily crash and break a driver, basically. The other thing you can do, which is what I'm doing right now, is unplugging a motor or unplugging an entire driver while it is powered up. That can very easily ruin a driver as well. And it's one of the common issues that might not be that apparent. So you can have a driver that you do unplug by hand, or a motor that you do unplug by hand. Obviously that's an issue and you shouldn't do that. But even if you just have a loose wire connected to one of the motor outputs, that can be very much of the same thing. And yeah, break the driver as well. Overheating is not much of an issue typically because these drivers, whichever one you use, whether it's a Allegro, TI, or Trinamic drivers, they all have a thermal shutdown. So really, if they get too hot, they're just going to shut themselves off. Now, speaking of the thermal shutdown, that might be something that you could confuse for an actual bad driver. So for example, if you have these tiny Allegro boards with the tiny potentiometer on it, and you set the current too high, it might feel like the driver is broken because it's cutting out every now and then, but it might just be that it's getting too hot and that the thermal shutdown is cutting in. What you can do in that case is just reduce the current ever so slightly on the potentiometer, and if it gets better, you know, okay, the cooling isn't up to par with what I was trying to do. Also, a motor that has, for example, metal shavings in there or a misalignment, that might give you the same symptoms as a bad stepper driver. But typically, these motors are extremely robust. Like there's not much to them. It's literally just a mechanical transducer, basically. It's a bit of steel, it's a bit of copper, and some magnetism in there, basically. That's all it is. Like these are really hard to break. And actually, they are the last thing I would check if you have an issue with your linear motion. Again, overheating with the motors, which is kind of an urban myth. These are rated to 125 degrees typically, minimum 105. So you can have a really hot motor, like you put water on it, it instantly boils, it instantly evaporates. That's still okay for the motor. It might not be fine for whatever it's mounted to, like if you have 3D printed parts that you screw your motor to, those are going to melt. But yeah, these are, very unlikely to break. And I guess one last issue that could be interpreted as a faulty stepper drivers is just the power supply into the driver not being up to par. So for example, with the ramps, where you have these two polyfuses in here, one is for the heated bed and one's for the motor drivers and the rest of the machine, these can sometimes cut out in a really weird way. So they might give you some symptoms that are completely random or can be misinterpreted for anything basically on the printer. So if you're using ramps that have the polyfuses, maybe try shorting them out on the backside, just solder something across these solder points. And if that solves your issue, then yeah, that's time to get rid of the polyfuses altogether. So let's actually go through how to replace these stepper drivers if you deem that yes, they are faulty. So first of all, with something like the MKS Gen, the ramps, anything that has plug-in drivers, you're typically going to have the plug-in Allegro drivers. The way you plug these in is you have the backside where it's labeled B1 or 1B, 1A, 2A, and 2B. Those should be facing the motor connectors. Plug those in, and that's good to go. Now, before you start using this, you definitely need to tune the current on these because by default, they are set to a rather high current, I'd say. If this potentiometer is in the middle position, that can mean anything on a driver. Not every driver is the same, but yeah, you will need to tune this for your specific printer and for your specific cooling situation before you can actually start using it productively. How to do that? I did make a video that kind of explains that. Watch that right there. So what you can also do with the unpluggable drivers, just to figure out whether it's the driver or the motor or anything else on this board, is you can actually swap two of these drivers. So for example, this is the extruder axis, but if you swap the X and Y drivers on the same board, and the issue you're having moves with the driver, then yes, it is the driver. If it's staying on the same axis, then that axis is faulty somewhere else, whether it's mechanical or wiring or a supply issue. That's up to you to figure out. But these really simple to replace and to upgrade, of course. You can plug in anything from an Allegro to a TI to a Trinamic driver into these slots. The next best option for replacing drivers is if you have onboard drivers that are soldered to the board, like here on the Smoothie board or on the Do It, but you have the pins broken out. So on the Do It, we have all these pins right here, which are labeled on the backside. So we have X, Y, Z, and extruder 0 and extruder 1, step, direction, and enable. Those are the pins you need to control a stepper driver. So typically that's all you need. The enable actually is optional. So basically you need step and direction. Step are pulses that trigger an individual microstep in this case, and direction tells the motor whether to go left or right. So that's all the info you need out of this board. And these are all broken out. That is fantastic. You can just take a breadboard or a, what are these called? Strip boards? Proto boards? Proto PCBs? And route those out to this PCB or the proto board and take those signals, feed them in here, connect your motor to the driver on a breadboard, and you're good to go. I'm going to show you how to exactly wire that up in a second. But what if you don't have those pins? What if you have something like this? Or actually, let's take this one step back. So the trams, Trinamic trams, also has onboard drivers, doesn't have anything broken out. There are no solder pins for these, but it's plugging into an Arduino Mega. So you have all these signals available at the spots where it plugs down into that Arduino Mega, and you can actually figure out which pins you can solder to and get your step and direction signals from this board. So that's really good. Your worst case would basically be something like the ANET A8 board, where you have nothing broken out, nothing really labeled, no standard pins, but saving grace right here, you have the test points around the processor, and those give you almost all signals that you need. We're going to look into how to figure out which pins these are as well. So figuring out which pins you actually need from your mainboard starts by opening up your firmware configuration file. If you don't have the Marlin source code for your exact 3D printer, check with your manufacturer, they should be able to provide it. Or if they don't or can't or don't want to, you might need to reconfigure a complete Marlin version from scratch, which is always a good idea. It adds new features. If you have a completely new version, you get the most up-to-date features from that directly as well. You're going to start by opening up your configuration.h file either in Arduino or in a text editor, and then scrolling down to where it says define motherboard and then your board name. That's the actual board name that your printer is configured for, which we can then use to figure out which pins do what. And we do that over here in the pins underscore and then your board name.h file. In our case, we're just checking for the standard RAMs configuration, which is kind of universal across many boards. And one of the first things you're going to see in there is the stepper section where it says define X step pin and then your pin number, X direction pin, etc, etc. These pin numbers are actual Arduino pin numbers. So for example, if you went into Arduino and said digital write pin and then status, those exact same numbers that you'd use for the digital write function are the ones that Marlin uses to configure their output pins. Now you have to keep in mind that these are not your standard digital write pins, these are actual analog pins, which are past the range of your digital pins. So there is a table that basically converts an analog pin number, so A1 to A12, 13, 14, however many your chip has, to your digital pin number that you can just plop in here like that. So once you have that pin number, you can take that and search for which physical pin that matches up with. On Arduino boards, like the Arduino Mega plus RAMs combination, you get these nice graphics that show you very nicely which software pins go to which physical pins. But if, for example, you have a board where the Mega is soldered to the board, you can also find these graphics which show you exactly what physical pin on the chip's package corresponds to which Arduino software pin. In our case, the X step pin is pin number 54, direction pin is 55, and then the enable pin is 38. Now, the thing about the enable pin is you don't need your own enable pin for every single driver. You can actually tie all of them together because typically you're not just going to enable or disable one axis, it's going to be all axes off or on at the same time. So if you're replacing more than one driver, you can just use a single enable pin. Many Pololo style driver modules will have their pins labeled on the bottom, but do keep in mind that as soon as you plug it in, those are going to be mirrored left to right. So let's start with the most important pins right there. The top one is step and the bottom one is direction, in this case yellow and green. Up top we have enable using the white wire. Below that there are the 3 MS pins which configure the microstepping mode, and basically you just want to tie them to your logic supply voltage, which in this case is 5 volts or 3.3, either one works, to enable 16 times microstepping. Your logic supply voltage also goes to the second pin from the bottom right, which is the supply input for the entire driver. And of course, wherever you feed a supply voltage in, you're also going to need to have a ground pin. Make sure that you have a solid ground connection between your motor drivers and your mainboard and your power supply. That makes sure that all your signals are going to be transmitted cleanly and without any hiccups in between. The Pololo style motor driver board has 2 ground pins, tie those 2 together, and between those 2 ground pins you're going to have your 4 motor outputs. And as always, if your motor then turns the wrong way, just flip the entire connection around. Now there are 2 pins left on the left side, and that's reset and sleep. Both are inverted pins. You can just tie those 2 together and the driver is going to work just fine. And on the right side, the topmost pin is your motor supply input. That's where you can connect your step-up converter if you want to increase your supply voltage to the motor driver, or just tie it directly to your 3D printer's power supply. That also works. Now, because we're dealing with relatively long wires here, it's a good idea to add decoupling capacitors. For the motor supply voltage, that can be a big electrolytic one, which will take care of slower voltage fluctuations. And wherever you use an electrolytic capacitor, it's also a good idea to add a small ceramic snubber capacitor that takes care of all the faster and more high frequency current demands of your board. So let's just go over all the external connections from the board one more time. Starting from the top left, that is enable inverted. Then we have step and direction, as well as the logic supply voltage, so 3.3 to 5 volts. Then top right, we have the motor input voltage, which can be 8 to 35 volts typically, the 4 motor outputs, and the ground pin. Make sure that it's solid, and you should be good to go. So one of the cool things you can actually do with having the driver externally on a breadboard, which is okay, I mean, this is going to work. Best option, of course, is using one of these proto PCBs and having some solid connections in the back. But yeah, if you have the driver external, you can give it whatever supply voltage you want. You could run it off of 5 volts if your driver supports that, but you can also grab one of these boost converters that steps up your supply voltage to whatever you set it to. These are like $2 or $3, and they can boost your voltage up to, I think, 35 volts, which is probably more than your driver can take. But for example, you can run your stepper drivers at 24 volts in a 12 volt system. That totally works. And it's going to give your drivers more torque. It's going to make them more silent in the case of TI or Trinamic drivers. And yeah, everything's just going to move more smoothly. It's going to make microsteps even work better. So use one of these. They have an input side, an output side, and you basically wire this between the supply voltage and the input voltage of your drivers. Again, with these modules on an external PCB or on an external breadboard, you should also not forget to tune the current. Same procedure as with a driver on the board itself. If your board uses software control, I think this is just fixed current, but if you have something like the Do-It where you typically have software control for current, that's obviously not going to be available unless you take the extra time and wire in the control bus. But yeah, you can use the potentiometer, that's fine, that works for most cases as well. So the nice thing with these breadboards is actually they have a sticky backside, so you can just stick these wherever on your printer. You can actually move this closer to your motor and have shorter leads if you want to. So it's a relatively clean solution. It's going to get your printer back working, and it's not going to have really any downsides in the long run, I think. Squarespace is the easy way to get yourself seen on the internet. Whether you're creating a portfolio for your work or want to set up an online store, Squarespace lets you create the website that is right for your needs. They will take care of the entire tech backend for you. There's nothing to install, patch, or update. Simply choose any of their award-winning templates, add your content, and it's going to look professional, no matter if your visitors view it on a smartphone or a big desktop monitor. Go to squarespace.com/sanladra now to get a free trial and 10% off your first purchase. So I hope that helped you get your printer back on track. Of course, there are so many different options with all these different boards. I'm hoping I could at least explain the most common ones. But yeah, as always, if you like this video, give it a thumbs up. If not, well, let me know in the comments below what I can improve on. Get subscribed if you want to see more. Support this channel on Patreon. Thank you to all of you who are already supporting this channel. And yeah, I guess I'll see you in the next one.